Our objectives are understanding fractional indices and simplifying expressions using the rules of indices. Okay, so fraction powers. Okay, so let's remember the rule that when we have a to the power of m times a to the power of n is equal to a raised to the power of m plus n. Okay, so using this rule, let us simplify this. We have a raised to the power of 1 half times a raised to the power of 1 half is equal to a raised to the power of 1 half plus 1 half, which is equal to a raised to the power of 1, which is equal to a. We have to remember that a raised to the power of 1 is equal to a. Now, then if a raised to the power of 1 half times a raised to the power of 1 half is equal to a, then a raised to the power of 1 half must be the square root of a. So therefore, a raised to the power of 1 half is equal to the square root of a. Okay, the same way, if we have a the same way as we have a raised to the power of 1/3 times a raised to the power of 1/3 times a raised to the power of 1/3 equals a raised to the power of 1, which is equal to a. So a raised to the power of 1/3 is is the cube root of a. So we have a raised to the power of 1/3 is the cube root of a. Okay. Therefore, we can say that a raised to the power of 1n is equal to the nth root of a. Okay, so let's try doing this one. Okay, let's find 9 raised to the power of 1 half. Okay, so we write it this way. So 9 raised to the power of 1 half is equal to the square root of 9, which is equal to 3. Okay, so if we have okay, so let's find out 32 raised to the power of 1/5. Okay, so we write it this way. We have 32 raised to the power of 1/5 is equal to the fifth root of 32. Okay, which is equal to 2. Okay, so let's have the harder fraction power. So let's say we have 27. Okay, so how can we work out 27 raised to the power of 2/3? Okay, so using the rule we have okay a to the m raised to the power of n is equal to a m n. So that means to say that if we have 27 and raised to the power of 2/3 is equal to 27 raised to the power of 1/3 times 2. Okay, so using the rule, okay, let's use the rule. We have to a raised to the power of 1 n 1 over n equals the nth root of a. So therefore, we have 27 and raised to the power of 2/3 is equal to the cube root of 27, okay, and then raised to the power of 2 is equal to, okay, 3 times 3 times 2, okay, we have 3 times 3 is 9, okay, so we have 3 times 3, 9 times 3 is 27, okay, so we have 3, okay, squared is equal to 9, because the cube root of 27 is 3, and then we have to square it because of the square there outside, so it becomes 9. So 27 raised to 2 over 3 is equal to 9. Okay. Then we have a raised to the power of m over n is equal to a raised to the power of 1n, okay, raised to the power of m is equal to the nth root of a, okay, then multiply it with m. Okay, so we have a m over n equals the nth root of a times m. Now, so we have now the 6 rules to help us, okay, with powers. So first we have um, a raised to the power of m times a raised to the power of n is equal to a raised to the power of m plus n. We have a raised to the power of m over a raised to the power of n is equal to a raised to the power of m minus n. So if we have a raised to the power of m raised to raised to the power of n is equal to a m n. So if we have a raised to the power of 1 of n is equal to 1 over a raised to the power of n. If we have a raised to the power of 1 over n is equal to the nth root of a. Then we have a raised to the power of m over n means the nth root of a m. Okay, and we have the uh, two special indices. So we have a to the 0 power is equal to 1, and we have a raised to the power of 1 is equal to a. Now, what about if we have this one now? Okay, working out powers. So let's say we have, let's work out. Okay, 64 raised to the power of negative 2/3. Okay, 2/3. Okay, so first we can have okay. So there are 3 steps to deal with this. Okay, first of all, we have the reciprocal negative power, the fraction splitting it up, and the roots and powers. Okay, so we shall take them one step at a time. So first, okay, we have 64 raised to the power of negative 2/3, okay, is equal to 1 over 64, okay, raised to the power of 2/3. Okay, then we have 1 over, okay, the cube root of 64, and then we have to square it. Then we have 1 over Okay, the cube root of 64 is 4. So 4 times 4 is 16. 16 times 4 is 64. So we have 4 and then square it. So the answer is 1 over 4 times 4 is 16. Okay. So let's work out the other one. Okay. Okay. We have the value of 8 over 27, okay, raised to the power of 2 over 3. Okay, so what do we do? Okay, so first of all, okay, let's have, okay, 8 over 27 minus 2/3, minus, raised to the power of negative 2/3 is equal to, okay, 27, okay, get the reciprocal over 8. Reciprocal of 8 over 27 is 27 over 8. And then we have 2/3. Okay. Then what will happen is, okay, we have here this one, 27 over 8, okay, raised to the power of 1/3, okay, and then multiply it by 2. Okay, so what happened is, okay, the cube root of 27 is, okay, cube root of 27 is 3, because 3 times 3 is 9, times 3 is 27, and the cube root of 8 is 2. Okay, and then we have, there's still square there. So we have now, okay, then 3 times 3 is 9 over 2 times 2 is 4. Okay, and then we simplify improper fraction. Okay, so 9 divided by 4 is 2, and remainder 1 over, okay, 4. So that's our final answer. Okay, what about if we simplify this one? So we have here, let's simplify this. We have the fourth root of, we have x to the 5th times x to the 7th. Okay, so what do we do with it? Okay, so first we have to multiply the inside. We have cube roots of 4, and then we have x 5 raised to the power of 5 plus 7. We're adding the exponent because we're multiplying the x there. So what happened is, we have the fourth root of x, okay, raised to the power of 12, and then we have, okay, x to the power of 12, okay, raised to the power of 1/4. Okay, then what we have now here is we have x and then 12 times 1/4, okay, is equal to, okay, x, okay, a quarter of, okay, 12 times 1/4 is 3. Okay, so that's the answer. So we have now here the fourth root of x to the fifth times x to the seventh is equal to x raised to the power of 3. This is our answer.